I did this and it's completely unsanctioned and off the hinge, and that's just how we roll here at level 1 because I was trying to thread the needle here. We're going to do a server build, and it's going to start with some amazing stuff, but it really ends with this brick of compute down here in the corner. That's why you're here, right? 256 gigs of VRAM, or 64 of the fastest server CPUs you can get right now. Okay, I wasn't entirely sure that this build was actually going to work because it is kind of heat dense, and so I've already been running it. But I want to walk you through what I did for the build. The star of the show is this. Radeon R9600Ds from ASRock. Single slot, 32 gigs of VRAM, that's RDNA 4. We've got 8 of them to get us to 256 gigs of VRAM. And for the case, it's Silverstone. It's the Silverstone CS383. This is available in a truly rack mount configuration, or you can get it in a tower configuration like I've got here. It's got 8 3.5 inch bays, and you can't see it, but we're basing this board around an ASRock Genoa motherboard. It has 8 slots, physically 8 PCIe expansion slots. Most motherboards only have 7. You're limited to 7. This one has 8 because I've added 8 add-in cards. If you take a look at this motherboard layout, you'll see that it physically has 7 x16 slots and 1 x8 slot near the top that is impossibly crowding the DIMM slots. You can use a single slot GPU in that slot and it will clear the DIMMs, but only DIMMs that don't have a heat spreader. Keep that in mind. I've already pulled a drive out. Yeah, so these are connected directly to the motherboard. There's 8 of them. They operate in SATA mode only. There's 2 other MCIO headers at the top. They can be PCIe or SATA, I think. I've got them in PCIe mode. Our high-performance Kioxia storage. Thank you, Kioxia, so much for supporting my mad science, because this thing has 64 terabytes of flash storage, and I've borrowed that for a while. Hopefully they won't ask for that back, because that's an insane amount of storage now. I mean, it's always been an insane amount of storage, but in 2026, halfway through, good lord, it's an insane amount of storage. But the real star of the show are our single slot, passive, 150 watt 9600D GPUs. So this is a 9600D GPU. It has 32 gigs of VRAM. It is 150 watts. There is no fan. It is designed for server levels of airflow. If you put this in a desktop, it's going to overheat and die. The thing is that these GPUs are not available on the open market. These are buy it by the case only, pretty much, from ASRock. The problem here is that everything is too freaking expensive. Literally everything. 8 of these GPUs gives you 256 gigs of VRAM. There is no less expensive path to get 256 gigs of VRAM in a system like this, period. A singular RTX Pro 6000, at the time that I'm doing this video, is $15,000. That one GPU with 96 gigs of VRAM costs more than all of these GPUs combined with their 256 gigabytes of VRAM. 96 gigs of VRAM versus 256 gigs. If I'm running inferencing, this is the better choice. The platform is a 9575F EPYC CPU. This is a CPU, server class CPU, that can do 5 gigahertz. We need a server class CPU because we need all the lanes, and we need a fancy pants motherboard like our ASRock Genoa motherboard here. A scary amount of this system is actually commercial purchase and doesn't really have anything to do with the channel. I just do this and consulting and like try to solve problems and that sort of thing. And not everybody's comfortable with me problem solving on camera, but this is one of those things where it's like, I don't know, I think we can figure this out. Let's actually try to do it. And running Tensor Parallelism 8 with 8 AMD GPUs, that's a little bit of an uphill battle. We'll talk more about the software side of it later. But the hardware side of it, there is a lot of considerations because these are all passively cooled. The chassis has to force an obscene amount of air from front to back. I think this is a little too loud to use as a workstation. Some of you would probably tolerate that, but really it's more server country, I think. For cooling, we're using a Silverstone XE360 AIO. This is pretty much the only industrial option for an AIO. Silverstone has some lower cost AIOs that would be perfectly reasonable in a workstation, but the XE360 is worth the premium if you're building a system that's, you know, north of $10,000. Another wrinkle are the fans. The fans at the midboard, you are going to need high RPM fans. I've chosen Arctic 15,120 millimeter RPM fans for this, and you can see they're like 35, 40 millimeters thick. You will also have to manually configure the IPMI on the motherboard to run those fans at a minimum of 70% in order to keep the GPUs cool. There's not really a closed loop sensor module like there in the IPMI. Sometimes in the system management bus, you can have the GPU report its temperature on the system management bus, and that'll be exposed in the IPMI. And in the GUI, you can add that as a sensor, and then the GPU sensor can be used to control the fans. And that's not an option when you're cobbling these things together. So you're going to have to set it to 70% manually all the time, and that's going to be responsible for some of the noise. But the trade-off is that you're saving tens of thousands of dollars to get to 256 gigs of VRAM. So I think you can probably live with it, right? Yeah, I mean, it's like this again. This is not a home computer. This is a business computer. This is probably not even going to be used for AI. This is probably going to be used for some field calculations that have to do with like plasma physics. But that's maybe a video for a different day. I taped over the vents. Why? To force the air to flow through the cards rather than over top of them. It's a little unusual, I know, but it's very effective at forcing more air through those GPUs. Because 150 watts each, I mean, they need the airflow. These two fans for the rear exhaust, they're also very effective at keeping the DDR5 memory cool. I'm running the DDR5 4800 in here. It's a little on the slow side, which is a tragic pairing. Tragic. With our 9575 AMD CPU, because that is the Cadillac of server CPUs right now. Single core speed, 64 cores, 128 lanes. What's not to love? It's glorious. It is fantastic for this because the CPU at the AVX 512 we're going to lean on just a little bit. Yeah, this is a this is a platform that needs airflow, not just for the GPUs, but also for the memory and everything else. And that really does it. So like if you needed to add hot swap NVMe or E1 or E3, there's an option. I would call attention to IC Dock's E1 dock that would work perfect in this. I have one of those and I've tried it in this chassis, not in this build, but in this chassis, and it worked fantastic. That gives you 8 E1 slots. All right, let's talk about the software setup and the options and what the PCIe layout looks like for this.
Here it is. Can you hear the song of my people? This is going to have to be a part 1 because I've run into some trouble when the system's fully populated with 8 GPUs. I think it's a BIOS problem. ASRock doesn't expose the number of bits for memory mapped I/O. Believe it or not, it's a resize bar type problem. I've got 8 GPUs worth of bar here. Only one of them will fit below the 16 terabyte boundary, I think. Oh, also, if you're going to do a build like this, I recommend you put tape over these vents because it'll force the air to flow through the GPUs, which is really important. And then you've got these also, which are helping cool the memory. That's why the noise. But check this out for the current state of things. So all 8 GPUs are showing up, and we've got the alignment, and only the first one has peer-to-peer access. And this is using AMD's own like peer-to-peer benchmarking diagnostic stuff. If we look at the peer-to-peer allocations here, it's like the first GPU picks that up, that's fine, and then the next one, and 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 the next one. But notice the addresses, because it is the subsequent ones are above the 16 terabyte memory boundary. And I think that's a BIOS setting, but this BIOS doesn't expose it. So you're gonna have to come to the forum and get, the forbidden BIOS, as seen in other videos, like what PewDiePie was working on.
It's a smoking fast system, no surprises there. The PCIe layout does mean that we have those 2 GPUs that only have 8 lanes for connectivity, but the other 6 GPUs have all 16 PCIe Gen 5 lanes, which was very nice to see, very useful for our setup, very useful for peer-to-peer. Sometimes it still makes sense to disable IOMMU for GPU isolation for even less overhead for GPU to GPU communication. Traditionally, I've had really good luck with that on 4 GPU EPYC systems. Your mileage may vary on 8 GPU EPYC systems because this is stressing the PCIe bus out to its maximum, much more than you would ever get in a normal server, because I/O and network are really not going to stress the fabric all that much. This they do, especially when they're doing math, especially when the math has been offloaded to a GPU and the GPU is basically able to work more or less independently. Another interesting thing about these R9600s is they do have DisplayPort out. So you could use these for applications that require DisplayPort out. A lot of enterprise GPUs don't have DisplayPort out. I think AMD could implement these with two R9600s on a single card. Certainly AMD's competitors have done that, and then that would give you a path to 64 gigs on a single card. Would be 8 lanes for each GPU, and you have to depend on the GPUs doing bifurcation. That'd be a little easier to juggle 4 cards in a box, and there'd probably be temptation to make them a double slot card so that you could have cooling and everything else, but that's maybe a conversation for a different day. For now, this is, I think, the most cost-effective way to get 256 gigs of relatively fast video memory in a single box for whatever it is that you might want to run that requires 256 gigs in a single box. Our guide in the forum, if you're going the AI route, our guide in the forum for TP2 and TP4, 2 and 4 parallelism with R9700 GPUs applies to these GPUs as well. But if you're going to go for 8, or you want more modern software, you got to get a little bit more into the weeds with our updated how-to. So be sure to check that out on the forum. There's a lot there. There's a lot of hard-won knowledge and suffering there. I'm Whittles Level 1. This has been a quick look at all of that. I'm signing out. You can find me in the Level 1 forums.